Hello, everyone, and welcome to a HopsWorks webinar. This webinar is being brought to you live on a wonderful sunny Wednesday afternoon in June. I'm here together with my colleague Alex Armenisan. We will be taking you through a couple of slides first and then some interactive demos a little bit later on that are going to try and introduce you to the AI governance features that we have in the HopsWorks MLOps and Feature Store platforms. We have a couple of things that we want to share with you, right? So a little bit of an intro, but then we'll also go into a little bit of the background and some of the concepts that we use inside HopsWorks before we then apply those concepts to our governance capabilities, right? And I think that's quite important that we kind of take a step back first, and then we dive into the actual governance capabilities. Alex has been so kind as well as to prepare a couple of interactive demos, right? So he's going to do that live on this webinar. That's going to be great. And then we'll recap at the end, and hopefully if you have any questions at that time, we can answer those as well or take those offline. So let's talk a little bit about the context here, right? And the concepts behind it. And the way I kind of think of this myself, and I'm just a farmer's son from Belgium, so to speak. But I like to think about this as a little bit of a paradoxical situation that we're in with the industry. The paradoxical situation in the sense that on the one hand, we all see, especially since we've been using things like Gemini or ChatGPT or Claude or any of the other tools out there, that the benefits of artificial intelligence and generative artificial intelligence are quite clear, right? They allow us to process a lot more data, do that in a better way, make faster and better decisions, drive innovation, drive efficiency, and actually, this entire ecosystem is moving up the value pyramid, right? So we're really seeing a massive benefit here, a lot of value coming from these AI systems. But at the same time, if you talk to any of the engineers that are actually building these systems, they will tell you that the complexity of these systems has exploded, right? It's become so difficult in some ways to build these systems, right? Because on the one hand, there's all of these different data sources, right? We have to combine all of these different data sources together at different cadences, right? At different periodic intervals. And all of these sources have different types and schemas, and that makes it really complicated. And from an engineering point of view, just the software that we have to write in order to make these systems work, that too has exploded in terms of complexity. So many different tools, so many different languages, so many different frameworks that people are using, right, in order to make these systems come alive. It's really, really not just a technical, but also a competency problem these days, right? It's really complicated. And then last but not least, if we really want to make these systems real-time, highly available, production-worthy, then, well, operationally, that complexity has exploded as well, right? Not in the least because also in terms of, the stuff that we're going to talk about later in this webinar, some of the governance characteristics have also been exploding in terms of complexity. And then I get to the final point here, of this AI paradox, and that is that, the bills are coming in, right? The costs are coming in, right? If you want to build these systems, right, it all seems quite easy and understandable and manageable at first until you then start to productionize it. The costs of these AI systems are very significant. So the paradox that we are facing is this fantastic value on the one hand, but the soaring complexity and all of the issues around it on the other hand, right? So how do we deal with this? Well, at HopsWorks, our philosophy is that in order to bring these things together, in order to solve this paradox, we really need to start thinking about MLOps, right? MLOps, machine learning operations, some people talk about model ops these days, or AI ops, all of these things kind of signify the same thing, in the sense that what we really need to do is we need to structure our method, to develop these types of systems a little bit more. And the way that we have come to do this is by basically structuring the software, structuring the mechanisms with which we build these models into AI pipelines, right? These pipelines follow each other. They form a system as a whole, right? And typically we talk about FTI pipelines, right? So feature pipelines, training pipelines, and inference pipelines. And then, as you can see in this this diagram here, it all is quite structured, right? So we build these production models in different distinct phases. We start with our enterprise data. We manipulate that data and we engineer it into features. We store that data probably in some kind of a dedicated system, a feature store. Then we use that feature data to train our models, to test our models, and to then deploy and serve the models on our production systems. And then finally, we monitor those models to make sure that they are still providing the optimal, most correct predictions to our users, right? And what we really need to do here, in order to solve this AI paradox, is to automate these steps, right? We really want to make sure that this becomes, machine learning as code, so to speak, right? That it becomes really easy and very difficult to get wrong. Why is this so important as well? Is because we know that there are different teams, different people involved in all of these steps, right? So we have data engineers doing the feature engineering and the feature storage. We have data scientists, very often people like mathematicians or those types of profiles doing the model training and model testing. And we have machine learning engineers that are actually going to develop the systems that will serve the model, that will do the inferencing, and then feed it back into a monitoring loop. The governance of these systems is going to be very often provided by architects or dedicated governance staff, right? And we will have to enable that. And the way we enable this, obviously, is by providing these MLOps systems, but to provide them in a specific way. The HopsWorks way of doing this is to do this around a feature store, right? We believe that if you bring the data together, if you succeed in bringing all the data together into a central repository that is dedicated for machine learning operations, your chances of bringing the teams and bringing the processes together are far, far higher. What is a feature store? Well, very briefly said, it basically means you have this central repository for AI, right? Where you do these pipelines, the feature pipeline, the training pipeline, and the inference pipeline. You structure the data, right? And you structure the data into specific types of abstractions that are dedicated to these pipelines, feature groups and feature views. Once you succeed in training a model, once your model is ready to go, you register the model in a model registry so that you can easily version it, so that you can easily deploy it, and so that you can easily use it in your predictions. This brings the teams together. This brings the data engineer, the data scientist, and the ML engineer together. This enables the governance of your AI systems. Right? And this is probably the point that I really want to tackle in this webinar. It's that not only do we see that the engineers love these types of systems, right? Because they have a worry-free platform that is pre-configured to host all of these workloads in a highly available, performance, secure, and manageable way. Right? The engineers love it because of that. But also the managers love it because it drives down cost. It drives down the economics of this entire system. It solves the paradox, right? And last but not least, we think that the governance staff will also love this because they will have a central point of control. This brings me to why an AI lakehouse, this is what we call HopsWorks these days, is going to help us with our AI governance. So let's tackle that topic. And then after I do that, I will hand it over to my friend Alex to show this to you. Tackle the topic, what do we mean with this, right? When we think about HopsWorks, when we think about the data platform for AI, the AI lakehouse that we want to deliver to our clients, that means that we want to allow them to create, reuse, share, and govern all the features that they need for enterprise artificial intelligence. We want to allow people to use their tools of choice and serve these models, serve these production AI systems at the lowest potential latency on any cloud and at any scale, right? So that's what we really want to do. The governance aspect is all about exercising some level of authority and control, right? We need to plan our systems. We need to monitor our systems, and we need to enforce certain types of processes over these systems. They need to be managed in a certain way, right? The quality needs to be assured, right? We don't want to be doing artificial intelligence or machine learning over bad data, right? We all know that bad data will deliver bad systems. We need to make sure that the policies, like for example, who gets to see what data can be processed in what way, all of these things need to be enforced, right? Specific regulations, need to be adhered to. We know that certain government institutions have certain rules that they need to comply with. But again, also the same thing in financial services or pharmaceuticals. Any regulated industry will have to deal with some level of compliance. We will have to be managing the risks associated with this, and you will see this later on as well when we talk about some of the specific regulations, right? Because many of them will require us to assess that risk and to have policies based on risk, right? We need to manage the business processes and the business policies, right? Because this is the way you provide AI data governance, not just for your internal purposes, but for your clients and your stakeholders as well. And so the question really that we want to ask ourselves is, is this different for AI than it is for enterprise data? Some people say, not really, and I can see their point, but it should be clear that there are some really interesting specific aspects that have caused people like the EU, but also the American government, Australian government, Singaporean government have issued specific regulations to make sure that these AI systems behave in certain ways. Since we're based in the EU, right, HopsWorks is a Stockholm-based Swedish company. I'll just briefly elaborate on some of the elements of the EU AI Act. Right, this is a piece of legislation, European legislation that has been in development for about 2 years or so, and it's now going to be published, and probably in August it's going to really be in effect, right? August 2024. What do we find in the EU AI Act? Well, the most important thing that we see in there is a risk-based classification of AI systems. Right? It's actually going to ask you as an organization to think about what risks are associated with the AI-based system that you want to productionize. Some systems, and we're talking about the obvious ones, are going to be unacceptable and are just not going to be allowed at all, right? Because they have risks to human safety, or that they provide risks to fundamental rights and values, or to public security, right? This is just not going to be allowed. There are going to be some exceptions for military purposes and intelligence and stuff like that, but by and large, these types of systems are just not going to be allowed, right? Then we have on the right-hand side, we have the non-high-risk AI systems. These are low-risk systems that have low risk to fundamental rights and values. And there will be very, very few implications to those systems, right? We don't really need to make any changes to our enterprise data protection and transparency requirements there. You know, it's the same old traditional regulations will apply. It's actually the middle category, the orange category in the middle here, the so-called high-risk AI systems that are going to be subjected to the highest level of impact, right? Because these systems will have automated decision-making that is going to significantly affect individuals in their daily lives, and therefore is going to have stricter conformity requirements in terms of data protection, transparency, human oversight, and the like, right? Specifically in the EU AI Act, you will find that before you can put these systems, these high-risk AI systems into production, you will have to look at those four aspects, right? You will have to do a conformity assessment. You will have to ensure human oversight. You will have to make sure that data protection and transparency are guaranteed, and you will have to monitor this. You cannot just do this once. You will have to do this as an iterative process and come back to it. Right? So this is how the EU AI Act is going to mitigate the risks associated with these systems, and at the same time still promote the benefits of AI to society. Right? So at HopsWorks, you know, predictably, I would say, we think that this is something that you can massively facilitate with a feature store-based MLOps platform. We think you can hit two birds with one stone here. At the same time, you can make it easier for your different stakeholders, your engineers, your data scientists, your managers, you know, all of these people will have an easier time in dealing with these AI assets, right? It will be much easier for them to understand these assets. And at the same time, achieve compliance. Two birds in one stone. Right? You don't just want to do this for compliance reasons. You want to do this for compliance reasons and ROI or efficiency reasons, right? And last but not least, before I hand off to Alex, we think there's actually some really interesting benefits to be had here in terms of a principle that has been very popular in academia and other research institutions, which is the FAIR principle, which is the fact that data and AI systems that are going to be developed according to these guidelines are going to be fair, right? They're going to have findable data, right? Which will allow you to find data sets really easily on a centralized platform like the HopsWorks platform. It's going to be accessible. You know, people will actually be able to say, okay, I need a feature for my machine learning model. Okay, well, I'm not going to develop this myself. I'm just going to access that feature and reuse it. It's going to be interoperable, right? Because everyone will be using the same types of features, and everyone is going to be, you know, therefore be able to interoperate with one another, and it's going to be reusable, right? So it's going to be able to be used in different systems, right? So the FAIR principle is actually going to be achieved by this way of achieving AI governance as well. So we would like to show you this. We would like to show you these capabilities, which is why it might be useful to spend the next 10 minutes or so looking at, first of all, some slides, but then also some interactive demos that Alex has prepared here. So if, Alex, you are ready for it, then I would hand off to you. And you will start by first explaining the AAA security capabilities, right? And then we'll go into monitoring and alerting. and we'll finish with metadata and provenance. These are like the 3 buckets of functionalities that are going to help us with our governance. Right, so Alex, if you're ready, here we go. I'll stop sharing and it's over to you.
Sorry. Can you see my screen?
Yes, we can.
Okay, so like you said, we will first start with some slides on security. So my name is Alex Ormenishan. I'm here for the technical part. And we start with the security part of governance. And this contains the 4 A's, so authentication, authorization, accounting, and auditing. You want to know exactly who has access to your data, how did they access the data, and you want to leave a trail so that people can investigate who accessed the data in what way. In HopsWorks, if we take the cloud version of HopsWorks running on AWS, we have on the left side the authentication and authorization integration. So a user can log into the platform using a user password method, but also well-known authorization and authentication platforms. We integrate with LDAP, we integrate with Kerberos, Active Directory, any Auth2 client. We have 2-factor authentication. So you can combine any type of authentication here. Then when the users get into the platform, we try to integrate with as many services as possible. So if services want to if we want to access HopsWorks, for example, from Databricks or from SageMaker, we can do so through the use of API keys. We can generate keys in HopsWorks cluster and use them in Databricks to access the feature store, the model registry. We aim to integrate with as many things as possible. We don't want to reinvent everything. We want to connect and make it easy for you to use the tool that you love. And then if you want to run something in HopsWorks as a job, maybe, you might also want to access services from within HopsWorks, like outside services. You are running in AWS. You want to access your Snowflake tables. You want to access your Delta Lake data. So you can do this on AWS in particular through federated IAM roles, right? Again, we try to make it easy and reuse anything that's out there to provide as much functionality as possible. Now, if we continue and look at the internal part, once you get through the authorization and get into the platform, even inside HopsWorks, all the data is encrypted. There's encryption at rest, and all the traffic is TLS enabled. So the services within HopsWorks also communicate with certificates. So we have X509 certificates in all the services. Applications that are running within HopsWorks also have their own certificates. They don't get shared. Each one gets generated, gets a new certificate generated. So we know exactly who's accessing your data in what context. Now, if we look at this from the perspective of a user that joins the system named Alice, and we also look at what she wants to do. She wants to access a number of services and wants to access data and might have some sensitive data there. So we have this notion of projects inside HopsWorks. This was probably presented in previous HopsWorks webinars, but I'll do a short presentation here as well. So the project in HopsWorks is just the sandbox that contains data, services, and users that have access to this, so the teams. Now, by default, these projects are like sandboxes, and we don't allow users to leak data outside of projects. So you can have sensitive data in here, and you can be sure that the data stays within your project. However, and we enforce this by making sure that, for example, Alice, as a user on the platform, has 2 different identities in each of the projects that she's a member of. She has two actual, like in technical terms, she actually has two users in the system, one for project A and one for project B. And the user for project A can only access services data inside project A. So we force Alice to keep data inside the project. But in order to allow for the FAIR principle, we also want to allow to share data, right? So even though the project is a sandbox where everything has to stay in, if you really want to, you can share data between projects. But we make the default that the project is a sandbox, and you know what that once you share the data, that data is moving now between projects, and you are aware of. This is a way again to know and to leave a trail of who shared the data. Look, data is being accessed, so you can audit this information. And what can be shared, like features can be shared, the database tables, so Hive tables can be shared, Elasticsearch indexes can be shared. We put all the logs for operational, like for services in Elastic. We put logs for jobs in Elastic. So all of these things can, by default, are sandboxed to a project, but they can be shared between projects as well. The second or the third A there was accounting and auditing. So in order to know and to make sure that everyone or make sure that we have a list of what everyone is doing, we have these audit logs, and everything like any access from outside of HopsWorks or from within HopsWorks goes through this REST API layer, and it's logged at this point. So all the operation, the user that is triggering the operation is logged onto the file system, which can later be used to, for example, look at the particular feature that you have in the feature store and see when was it created, who created it, when was, like, which job created this. Again, this is a computation that was running inside a cluster. Maybe you also ran some statistics, some data validation. Maybe you inserted some new data. All of this are visible in the audit log of each of your feature groups. So now you know exactly when something happened to your feature group, to your data that you're interested in. After we deal with authentication, authorization, accounting, and auditing, we want to also enable anyone to, or any member of the project, and to monitor and to know when something goes wrong. And the monitoring part goes from operational, so services, to jobs. So when you run a pipeline, to data itself, when the data that's coming into your system is different, is somehow broken, we want the user to know it and to be able to get alerts for it. We do this through the integration of Prometheus. So here, Prometheus is in the center of the slides. We collect different metrics in Prometheus, and we set up a number of alert rules in Prometheus. And if those alert rules say that something is off, they will trigger and send an alert to the alert manager, which will then be configured to send this alert further to email, Slack, or PagerDuty, or some other integration that you might have. And the metrics are collected at the node level by the node exporter. So we collect information about how much memory is used by services and nodes, how much disk space is used by the two, is a service overloaded or not. We collect these metrics, and based on rules, we detect this overload and trigger alerts. We also do this monitoring at inside HopsWorks now at the job level. So whenever you run some computation, you can set alerts to know the job ran, the job failed, there was an issue, I want to know as soon as possible. We do this at the feature store level, and we do data validation. And this is like specifically when the data is entering your system, we use Great Expectations, and you can set a number of rules there to validate and clean your data and make sure that only clean data is stored into your system. And then you go one step further, and we do feature and model monitoring. So you want to know when your model is misbehaving according to some rules defined by you, so that you can retrain it and deploy the new model into production, because the old one was, for some reason, had some drift or something and is now not according to your standards. From operational perspective, this is the view that you would get in Prometheus and Alert Manager. On the left side, you would get a number of alert rules. So you define these, you see a level of severity that you can set it to. It's a type of like this, for example, I have an Aeroflight service being down defined as a system alert. And the important part would be the expression. So that expression, based on metrics collected by Prometheus, if it's true, it will trigger an alert. That's the trigger for the alert. And if that's the case, then an alert will be sent to the alert manager, and further to an email, to a Slack channel, to some place where you can take account and take action as soon as possible. Data validation. So in this case, we use Great Expectations, and you can set rules such as minimum, maximum on specific columns of your data. You can set uniqueness properties there. You can set not null, for example. So you can decide if you want to just be informed that your data has some null values, or you want to block it all the way and make sure that only data with where all the columns have values is inserted into your feature store. So you have a level of flexibility here. And then you can view the validation report. You can view when the validation was done in your audit log. So you can combine these things to make sure that your data is correct and the data check was run at the correct time. More information on the data validation is in the webinar that I linked in the slide. So there we go more in depth into data validation. But I will also show you how the code looks for this. So it's a simple, you create a number of rules with a name. The level of that's set there will decide if your data goes in or not. On error, for example, your data will not get into the feature store, and you will get a notification that there was an error on the validation. But you can also set it to warning to still get some sort of notification, or just info if that's okay with you. So you set a number of these rules, you attach them to any feature group that you need, and then you check the alerts, you check the audit log, and you make sure that everything works. Was there a message in?
Alex, that was my mistake. I sent it to you, but I intended to send it to everyone. Sorry, my mistake.
Okay, I can take the messages at the end and go through each question on any topic in the FAQ. Okay, so after data validation, you go and you have a model, you train the model, you deployed it, you are doing inference requests, and now you want to monitor your model, because you want to make sure that the model behaves as you expect. So you will get the predictions, and you will get the inference data, sorry, and you will get some more, you will enrich this inference data with some data from your feature store to give it some context. And then you will send it to the model to do a prediction. And you'll send back the prediction to the application. But you will also log this into a Kafka topic so that you can monitor and make sure that your model is behaving correctly. Okay, you want to detect this drift. If this happens, you want to retrain the model and redeploy the model. But now the question is the model actually degrading here, or is something else degrading? And the idea is that the degrading part is not the model. The model behaves exactly as it should, as like the data that it was trained on, but your data can definitely change. So the ingested data can change over time. The input of the model can change, and the patterns in the real world can change. So even though at training time, everything was okay, for a time your inference pipelines were okay, at some point, something makes it that it's in some way wrong. And you want to actually monitor not just the model for this, but the input data. And this data shift can happen like before the training data set is created, or like at any point in time, at like feature engineering, training data set, or even later on, it can appear inside the model. So you want to detect this data shift at any point in time, not just for a model. So when we will compare current data with a base model of the data, you have the opportunity to set this base to any time in the past that you consider to be like the normal data, or to the training data set in case of models, or to like you can set it to any window. And the feature monitoring code would look like this. It might look like quite a bit of code, but it also includes some descriptions in there. So you can give it a name, and you can give it a cron expression. How often do you want this to run? And then you give it the detection window. So what data is it looking at? What's the new data? And in this case, it's the last hour of data. And you want to look at the percentage of this data, because maybe you don't have the resources to look at all the data. And then you want to give it also the reference window data. So you want to like, what do I compare this new data to? And in this case, it was the training data set. So the training data set that was used to train my model. And what exactly do I compare it on? What am I interested in making sure that it doesn't go over, for example, or what do I compare with? In this case, the mean, and it has a threshold of 50. So if it's off by more than 50 units, then someone has to be alerted by this, and you need to know about this issue. And again, the feature monitoring was presented in a previous webinar, and I linked it here, so you can go and look at this into more depth. Now for the micro demo, we will go into the HopsWorks platform. And first of all, so all the code that we use, it's in GitHub. So there is this HopsWorks tutorials, which is a public repository. You can fork it, and you can try to run the tutorials yourself. And you can fork it in, you can clone it also inside HopsWorks. So as a part of our attempt to be fair, we also want to be sure that we allow the collaboration between people on the platform. So how do you clone something in HopsWorks? You configure, you go to your account settings, and you set up your Git account, your Git credentials. What exactly? So a username and a Git API token. So this token you generated in GitHub. You set it to how long you want to use it. It has a window where it's valid. You can delete it, and it's this simple. And then when you want to clone a repository, like our tutorials in this case, you go into settings, into the Git section. You clone the repository. You get your HTTPS link from GitHub. You select a different branch if you want. You select the location where you want to clone it, and you will then see the number, like the Git executions that occurred here. You can push code, you can pull code, so you can see a history of what happened. And in particular for the HopsWorks tutorials, you can also view these files once you clone them. Once you clone the repository, I clone them into Jupyter. So I will go through two files in here, or two small tutorials in the integration. And this is the Great Expectations for the data validation and the feature monitoring. But before that, let's start with the alerting. So in the first section, I was saying you can configure alerting and you can collect metrics. We do this with Prometheus, and Prometheus is at the center of this monitoring and alerting part. And as we've seen, there are a number of alert rules that come pre-configured with Hopsworks to know if a service is down, if there is an out-of-memory problem with your service or with your node itself, is your disk filling up? And we already went through, if this expression for the alert rule is triggered, we will see alerts popping up in the alert manager. These alerts in particular are alerts that do not have a sink to go to. Like they don't, for example, there was no Slack channel configured for this. There was no email configured for this. So they are saved in the alert manager so the user can come at a later time and inspect them. And some of these alerts, however, could be expected. You might have a hardware malfunction that is expected, and your infra team says, we will fix this machine within 24 hours. So expect this alert to go on for 24 hours, but then it would pollute your alert logs. So you can just silence it and for 24 hours and just keep track of your other alerts. Now, how do you connect the alert manager to Slack, for example? Well, we go into the cluster settings, and this is a setting that's available to only to administrators. So the administrators will set this up for the whole cluster, and then each user can set specific alerts for their own projects. So we go to alerts, and you can configure the email, Slack, and PagerDuty in here. And our mantra is to make things that are used often as simple as possible, but also allow for any edge case that you want. So if these three are not what you're looking for, you can just go to the advanced configuration and go deep into the JSON that's used to configure the alert manager and set your own receiver if it's not email, Slack, or anything that we've provided. And for Slack, for example, if you want to configure, you just have to get a Slack hook and say on behalf of whom do you want to trigger the alert. And the Slack hook, for example, is very simple to configure. If I go to my own Slack, I just go to apps, I search for webhook. It should be an incoming webhook. You click on add, you go to Slack, it goes to my own workspace. I say, yes, I want this integration with my own Slack. And then I look for my channel, and it's the webinar channel now. Yes, and I add this integration to my webinar Slack in the Hopsworks space. I copy this, and this is the webhook that you need. So you take this, configure, you set it here in webhook, and now your receiver for the alerts is configured, okay? And this is the admin's work. He sets this, and then it's done for everyone. Then the user would go into their own repository, into their own project, and for example, they want to make sure that a specific job triggers alerts on, I don't know, some event. Let's say that we have this hello world, very simple job, and I want to set an alert to know even when the job was successful. So I can add an alert. I have different triggers, and we will have different triggers for different abstractions that we will show you. And in this case, there's three things that you can do, and let's pick the success. We pick the receiver, so the Slack that we just configured, and we say this is an info level severity because it's success, right? So after this, we can just run the job, and when it's done, we should see an alert popping up in the webinar demo. So for example, it shows here that just now I added the integration for the webhook, but this was just for demo purposes there, right? So the job succeeded, and soon there should pop up a job execution alert. So we know it ran. this is probably not what you want. You'll put it when it fails, right? Because you don't want to get a gazillion alerts. But maybe there's also some important jobs that you really want to know that they ran correctly. After this, you want to check your input data. So you go to data validation. You go to the, again, to the HopSearch tutorials. You go to integrations. You go to Great Expectations, and you run the fraud batch data validation tutorial. This will set up, among other things, for example, specific, like I said, rules. I want a specific column to be between 17 and 130. I want, there can be some uniqueness purposes there and so on. And then if you run the whole tutorial and you follow the tutorial link that I showed you, you will see that you will get a feature group. So the Great Expectations Transactions feature group. And this will have a number of validation reports here that you can look into, so you can monitor what has happened. But you can also add, again, the same alert, but this time you'll have different triggers, right? And again, we can pick on data validation success. I want, again, a message in Slack. And again, it's info because it's success, right? So we save it, and I go into my Jupyter Lab, and I go into my small dataset validation test, which is a subset of the data of the Great Expectation tutorial, where I just load some data and do some very small engineering on it. I connect to HopsWorks, and then I insert my data. First you get the feature group, and then you insert your data. And when you insert the data, a validation, like the validation step is happening. This validation step was set up in the tutorial. And you will now see another, I didn't check the date exactly, but you will see another report running here, but my time zone is probably different. And you will also see, you should see a validation alert triggered by the alert that we just set on this validation step. And the third part that was discussed before was the model monitoring, and specifically also the feature monitoring. So you want to compute specific feature statistics and make sure that the data that's coming in right now is very similar to what your model was trained on, so you can detect the drift. So you will go into the HopSearch tutorial again, into the integrations. You will run the feature monitoring tutorial. Again, there was a link in the slides which goes into more depth of what is happening here, but it's just configuring these windows and you know, the detection window, the reference window, and what do I compare on for different features. And if I go to the feature group that is created, this transactions feature group, we will see in the feature monitoring that we have these monitoring windows set in here. And again, you still have the same alerting, and you can set, for example, some feature monitoring trigger for some shift that was detected or maybe not detected, just to give you a sense of safety that the data is still okay, it's still good. So you put it at info, and you can either run the drift, or we can just also test here that before running everything, our alert is set up correctly. So you can set up alerts, and you can monitor jobs, feature groups, and models. And you can also do operational monitoring. All the logs are also logged into OpenSearch dashboard. So you can see the logs, for example, of a specific job. If I go into the very basic Hello World job, I can see my when it's running, I can see a live logs. And actually, if I run it, but the job might be too fast to see. So it will show us the OpenSearch dashboards and eventually I will see the logs. No, too fast. So it has to pull them in Elastic and see them later to inspect and see what happened in your system. Now, after the monitoring and alerting has happened, I will continue from the metadata. So slideshow. The second part of this demo is, like, for proper governance, you want to be able to annotate your data properly. You want to be able to search for the data to find it, and you want to see how the data flows between different abstractions, to see what the model was trained on, for example, to the very beginning. And in this case, we use tags, schematized tags. And why are they schematized? So they have a schema, they have a type, and they are complex. It's not just a key value. The value itself is a complex object with values of its own. And you can attach these tags to anything in the system, but in particular to feature groups, models, training data sets. You can set who is responsible for this training data set. You can set some specific things that you want to search for, like we see on the right, and like I'll show you in the demo. And the second part is the provenance. So like I said, you want to see the flow of data from the very raw data to the training data and to the model. So at the moment, HopsWorks, for example, provides these links between storage connectors, feature groups, feature views, training data sets, and models. So you can see a graph of all these things. And I will go into the demo again. And we will show you now the first the schematized tags. So the tags themselves, the schemas, are created again by an admin because it's defined at the cluster level. So the admin will go to the cluster settings to tag schemas. And in here, I have a simple one tag with like location and two fields, city and country, but we can create a new one. And again, we try to make the general case easy. So if I, let's say, responsible person for something, can add a description for what it is, and then I can add some properties. I can add an ID, which should maybe be an integer. Maybe it has a last name. You can give it a proper description, first name, and so on. And if you want more complex tags, you can also, again, go to the JSON editor. And in here, you can put any schema that's compliant with the JSON-schema.org. So this is, again, a standard, and we are compliant with it. And you can paste your arbitrarily complex schema in here and attach tags like that to anything you want. So create. And then again, we will see the responsible schema with the fields that were defined. And the admin defines it once for everyone in the system. And then a user goes in their project and goes to a feature group, for example, goes to this transaction feature group that we just created and would attach, for example, the location, right? But maybe I want to add another one. We just added the responsible, Alex, Nishan, some ID to it. We save it, and you can just add. So you can add tags that are defined on, like this responsible. I can add it on models, feature groups, on everything, and then I can search for this data, like for these artifacts based on. So transaction, this would be some part of the name, but I can also check, for example, for Sweden for the location, right? And it will show me that now the search matched the tags, and maybe it's important for you to search for something for the things that Alex is responsible on, right? And like I said, you can attach this to anything you want. And the last part would be the provenance. And in there, if I go, for example, let's go this time to a model registry. see a model here, go to the model itself. And this would be the provenance of this specific model. So it tells me this is the demo model. It was trained on some training data, which was materialized from this particular feature view, created from a particular, on this particular feature view, created from a particular feature group that is also some aggregation of some other feature groups. And one particular is an external one, actually, and it uses a storage connector to go maybe outside of HopsWorks. In this case, it's actually going inside, but it's going to the file system directly. But this could be a JDBC connector, anything. And then you could, for example, just jump to that particular thing and inspect it further and see maybe it was used in something else, because then you get the provenance view from that particular artifact's perspective. And the last thing, you see this provenance here, but you can also use it programmatically. Again, if we go integrations, provenance, and in use, if I run this, okay, you connect to HopsWorks, and then you get a specific feature group that you start with, and then you want to see what feature groups were generated by this from this feature group. And in particular, since you can share data, you can see the accessible ones, and you will get a usable feature group, but you can also see the inaccessible ones. But there you would only see the metadata, so that you can go and contact the team of that project and say, I saw that you're also using or this particular feature group. Can you tell me tips and tricks, for example, right? And you can see generated feature groups. You can see parent feature groups. Again, the parent of this particular one was the demo external feature group, or one of them. If I check a different one, it's the demo feature group 1. And from the first feature group, we can see what feature views were generated. So you can combine this and go down to models, see the models that were generated. And actually here, let's see the name and the version of it. And better on, maybe you want to see the newest model. And in this case, it's the same, but it will check which one's the newest one. And we are planning to add more, like most recent, most used model or things like this. So you can use this provenance to, for example, see the usage, which is the most used feature group in your own feature store. Or, for example, as a work in progress, there is a feature coming where you could look at, if I delete something in particular, what else would I impact, right? If I delete this feature group, I would also impact a particular feature view that's generated from it. Do you really want to do that or not?
Thank you so much, Alex. That was a very elaborate micro demo to do here. And what I hope we have learned here is that, when we think about AI and machine learning, I think we can all agree that it's really powerful, but complex, right? We can manage that complexity totally. We know how to do that through a combination of MLOps processes and tools, right? And we have also kind of demonstrated in this webinar that the AI Lakehouse, the HopsWorks infrastructure, provides you with a great piece of infrastructure that can act as a forcing function for implementing MLOps, right? This doesn't only bring you great technical and productivity benefits, but it also really helps you with AI governance. And that was the whole point of today's webinar. Let me also stress here that the capabilities of HopsWorks are available on any platform, right? So you can start with HopsWorks, just running it off of a serverless environment. We provide that for free to all of our users. We have thousands of people sharing that infrastructure. We can also deploy it inside your cloud environment, AWS, Azure, but also GCP. And then obviously for clients that have very strict AI governance regulations, I think of government institutions or regulated industries in general, that have private data that they don't want to be sharing with OpenAI or the likes. Well, for those people, we actually provide our capabilities on their infrastructure on-premise or in their sovereign cloud environment. So we provide a lot of capabilities there. We warmly invite you to give it a try. Join our community, join our Slack, and explore some of the tutorials that Alex has also shared with you. I want to thank you for joining us today. Have a wonderful day, everyone.